Welcome back to the online class of Milestone College. My dear students, today I am going to discuss about the chapter 4, and this is the thermochemical part of chapter 4. Dear students, first you have to know what is thermochemical reaction, and this is a very common reaction that nitrogen gas reacts with hydrogen gas to produce ammonia gas. In this case, the delta H value is minus 92 kilojoule. Dear students, if you observe this equation, you will see that in this reaction the physical states of both reactants and products are mentioned, and again the delta H value is also written with the reaction. I mean, you know that delta H represents the heat change, the amount of heat change in a chemical reaction, and here 92 kilojoule heat is evolved. That's why this is a thermochemical reaction. And you know that when the value of delta H is negative, this is exothermic reaction. And again, if I write the reaction oppositely, I mean ammonia gas breaks to produce nitrogen gas and hydrogen gas. Here also the delta H value is 92 kilojoule, but it is positive. I mean the values of both equation are equal, are same, but the signs are opposite to each other. This is known as Lavoisier and Laplace law. Actually, my dear students, I would like to discuss about the thermochemical laws. I would like to mention here thermochemical laws. There are two thermochemical laws, and those laws actually based on thermodynamics. The first one is Lavoisier and Laplace law. Already I have told you the change of heat of a chemical reaction. The change of heat of a chemical reaction is exactly equal to the change of heat of the reaction in the opposite direction, but their signs of heat changes are opposite. I mean, in the first one equation, during the ammonia production by the reaction between nitrogen and hydrogen, the heat change is 92, minus 92, and again if I write the reaction oppositely, in this case also the heat change is 92, just the sign will be opposite. I mean, as it is an exothermic reaction, but the opposite reaction will be an endothermic reaction. I mean, here the heat is absorbed. This is Lavoisier and Laplace law. And second one is Hess's law of constant heat summation. Dear students, first I would like to show you a diagram. Here the reactants carbon and oxygen and the product carbon dioxide are constant, and here actually I would like to say you that carbon dioxide can be produced from carbon and oxygen directly through one way, and in this case the change of heat, I mean delta H equals to minus 393.5 kilojoule, but in the presence of insufficient oxygen, carbon reacts with insufficient oxygen to produce carbon monoxide, and again this carbon monoxide reacts with atmospheric oxygen to produce carbon dioxide. Actually, I would like to say you that carbon dioxide can be produced through two steps, and at the first step the delta H value is minus 110.5 kilojoule, and at the second step the delta H value is minus 283 kilojoule, and the sum of the both cases, the sum of the delta H values of both cases is minus 110.5 plus minus 283 kilojoule equals to 393.5 kilojoule. Again, if the reaction, if carbon dioxide is produced in directly by one step, in that case the delta H value is minus 393 kilojoule, 393.5 kilojoule, which is equal to the sum of the delta H2 plus delta H3. Actually, I would like to say you that delta H1 is equal to delta H2 plus delta H3. Dear students, if I write this reaction directly, it will be like this: carbon solid plus atmospheric oxygen gas equals to carbon dioxide gas. Here the delta H value is minus 393.5 kilojoule. Again, when the reaction occurs by double steps, in that case at the first step carbon reacts with insufficient of oxygen to produce carbon monoxide gas. Here delta H value equals delta H, if it is delta H1, it is delta H2 equals to minus 110.5 kilojoule. Again, carbon monoxide gas, the second step, carbon monoxide gas reacts with insufficient oxygen to produce the final product carbon dioxide. Here delta H3 equals to minus 283 kilojoule. Dear students, now if you write the values, delta H1 equals to delta H1 equals to delta H2 plus delta H3, or minus 393.5 equals to minus 110.5 plus minus 283 equals to minus 110.5 kilojoule. Actually, I would like to say you that delta H1 equals to delta H2 plus delta H3. Heat of formation. Dear students, already I have shown you a reaction, production of carbon dioxide gas. Carbon dioxide gas is produced by the direct reaction of its component elements carbon and oxygen, and in this case the change of heat is minus 393.5 kilojoule. So the heat of formation of carbon dioxide is minus 393.5 kilojoule. Heat of formation is calculated in case of 1 mole compound, 1 mole product. Now what will be the definition? The heat change, the heat which changes during the production of 1 mole substances. Suppose here I used carbon dioxide. from its components elements, I mean carbon dioxide, the component elements of carbon dioxide are carbon and oxygen, is called heat of formation of that substance. I mean heat of formation of carbon dioxide is minus 393.5 kilojoule. Dear students, heat of formation is also denoted by delta HF. So I can write here delta HF carbon dioxide equals to minus 393.5 kilojoule. Okay, again look at the whiteboard. This is heat of dissociation. Heat of dissociation is actually just opposite to the heat of formation. In this case, if I show you an example, suppose 1 mole of water, liquid water, if I pass electricity through the 1 mole of water, here this reaction will occur here. Hydrogen gas, it breaks to produce hydrogen gas and also oxygen gas, and in this case delta H value equals to plus 285.85 kilojoule. Dear students, actually I would like to say you that 1 mole of compound breaks to produce its component elements, and that time the change of heat is actually known as heat of dissociation. So what will be the definition? The heat which changes during the breaking of 1 mole compound, here I have used water, 1 mole of water, to its components elements, I mean to hydrogen and oxygen, is called heat of dissociation of that compound. I mean heat of dissociation of water is plus 285.85 kilojoule. Dear students, this is heat of combustion. If I burn carbon in the presence of sufficient amount of oxygen, then carbon dioxide gas is produced. Here 393.5 kilojoule heat is evolved. It means the heat of combustion of carbon is 393.5 kilojoule. Dear students, it is noted that heat of combustion of carbon and heat of formation of carbon dioxide are same, and the value of delta H is also same, I mean minus 393.5 kilojoule. I mean I can write here heat of combustion delta HC, I mean heat of combustion of carbon delta H equals to minus 393.5 kilojoule. And again I can write also heat of formation of carbon dioxide equals to minus 393.5 kilojoule. Both are same actually, because to produce carbon dioxide you have to burn carbon in the presence of sufficient amount of oxygen. That's why the combustion, heat of combustion of carbon and the heat of formation of carbon dioxide are same to each other. However, the definition is the heat which evolves during the burning of 1 mole of substance in the presence of sufficient amount of atmospheric oxygen is called heat of combustion of that substance. My dear students, heat of combustion is also calculated in case of 1 mole substance. And again, heat of solution means a definite temperature if 1 mole of solute is dissolved in sufficient amount of solvent, then the change of heat is called heat of solution of that solute. Suppose copper sulfate salt. This is the copper sulfate is an ionic compound, solid ionic compound, and if I dissolve copper sulfate in the presence in the sufficient amount of water, in that case each of the molecule of copper sulfate combines with 5 molecules of water, to form a crystal which is known as blue vitriol, and it is also blue in color. So the heat of solution of copper sulfate, so I can write here heat of solution of copper sulfate is minus 66.04 kilojoule mole inverse. Heat of neutralization. At room temperature, the heat which changes during the production of 1 mole of water in the neutralization reaction is called heat of neutralization. Dear students, you know that the reaction between acid and base to produce salt and water is called neutralization reaction. In neutralization reaction, during the production of 1 mole water, the change of heat is actually known as heat of neutralization. And again, bond energy. Dear students, now I would like to show you first an example, that is methane. You know that one carbon atom is bonded with 4 hydrogen atoms, and the total energy of 4 hydrogen atoms, energy of 4 carbon hydrogen atom bonds is 1665.32 kilojoule. So the average energy is equal to 1665.32 divided by 4 kilojoule mole inverse equals to 416.31 kilojoule mole inverse. Dear students, normally in case of breaking of bond, the heat is absorbed. Dear students, actually chemical energy are stored. Chemical energy is stored in the chemical bonds, which is known as bond energy. Now look at the definition. The mean energy, the average energy which changes during the breaking of same bonds present in 1 mole of any substance is called bond energy. Heat of neutralization of strong acid and strong base is constant. Dear students, I would like to show you the 2 reactions. Sodium hydroxide, this is a strong base, and hydrochloric acid, this is a strong acid, to produce here sodium chloride and water. Dear students, in this case delta H value is minus 57.34 kilojoule. Actually here hydrogen chloride, hydrochloric acid ionizes in the aqueous solution to produce hydrogen ion and chloride ion, and sodium hydroxide ionizes in the aqueous solution to produce sodium ion and hydroxide ion. Here actually sodium ion and chloride ion exist in the reaction system as spectator ion, and only the H plus ion and hydroxide ion combine together to produce water, Actually, I would like to say you that here actually only 1 mole water formation reaction occurs. And again, if I consider nitric acid ionizes in the aqueous solution to produce hydrogen ion and nitrate ion, and potassium hydroxide ionizes in the aqueous solution to produce potassium ion and hydroxide ion. Here also potassium ion and nitrate ion exist in the reaction system as spectator ion. I mean, they don't take part in the chemical reaction. Only hydrogen ion and hydroxide ion combine together to produce water. Here also 1 mole water formation reaction occurs. Actually, dear students, I would like to say you that whatever the strong acid or base, it is not my headache. In all cases 1 mole water formation reaction occurs. That's why the delta H value is minus 57.34 kilojoule in all strong, in case of all strong acids and bases. And again, dear students, heat of neutralization reaction, heat of neutralization of weak acid and strong base is less than the constant value. Look at the whiteboard. Suppose this is ethanoic acid. You know that ethanoic acid is a weak acid and sodium hydroxide, this is a strong base. Here actually if I write both of the ethanoic acid and sodium hydroxide right in the ionic form, in the aqueous solution ethanoic acid ionizes partially to produce ethanoate ion and H plus ion. Again sodium hydroxide ionizes in the aqueous solution completely to produce sodium ion and hydroxide ion. Here actually ethanoate ion and sodium ion exist in the reaction system as spectator ion, and H plus ion and hydroxide ion react together to produce water. Here actually also 1 mole water formation reaction occurs, but and the delta H value is also minus 57.34 kilojoule, but as ethanoic acid is a weak acid, 2.2 kilojoule heat is used for breaking the unionized ethanoic acid. As ethanoic acid is a weak acid, you know that big amount of ethanoic acid will not ionize. That's why 2.2 kilojoule heat of minus 57.34 kilojoule heat is used to breaking, to ionize the ethanoic acid again. So the delta H value is decreased, and it is decreased from minus 57.34 kilojoule to minus 55.14 kilojoule. That's why the change of heat of weak acid and strong base is less than the constant value, and that is approximately minus 55.14 kilojoule. Dear students, heat of neutralization of hydrogen fluoride and sodium hydroxide is more than constant value. I mean it is more than minus 57.34 kilojoule. Dear students, look at the reaction. Hydrogen fluoride reacts with sodium hydroxide to produce sodium fluoride and water. Here the delta H value is minus 68.60 kilojoule. So what is the reason of the more delta H value than minus 57.34 kilojoule? Here actually you know that hydrogen fluoride ionizes in the aqueous solution to produce hydrogen and fluoride ion, and as well as sodium hydroxide ionizes in the aqueous solution to produce sodium ion and hydroxide ion. And sodium ion and fluoride ion exist in the reaction system as spectator ion, and as well as hydrogen ion combines with hydroxide ion to produce water. Here actually minus 57.34 kilojoule heat is changed, heat is evolved, but the size of ionic size of fluoride ion is smaller. That's why it combines with the polar hydrogen water molecules very strongly. In that time one kind of heat is also evolved, which is known as hydration enthalpy or hydration energy. This hydration energy is approximately minus 11.26 kilojoule, which is added with the heat of neutralization, and finally it evolves 68.60 kilojoule heat. That's why in this reaction the value of delta H is more than 57.34, it means constant value. My dear students, that's all about the theoretical part of this chapter, and in our next lecture I will discuss about the creative questions of this chapter. And already I have told you this is a very important chapter and you will get minimum 20 marks from this chapter. So you have to study this chapter sincerely, and also you have to follow my next lecture on creative question. And no more today. Goodbye.